Hi, we are back for our third session of the day, and now we will talk about start building machine learning models faster than you think. So, what we will discuss is what is machine learning. We've already talked a bit about it. We will recap certain things. Then, when is machine learning the right tool for you? How Azure Machine Learning Service tools will make your life easier, and then we'll build a time series regression model with Azure Machine Learning Interface, and that's a tool that allows you to build a model with drag and drop modules. And lastly, we will deploy the model we create and test it out. So, our use case. We've already talked a lot about tailwind traders in previous sessions, so our use case is linked to that again. So, Tailwind Traders is a retail store and they realize they are losing sales due to empty shelves at one store and full ones at another. And they want to be able to predict how many items each store will need to make sure that they can accurately meet demand at each store and not over or understock each store at an item. And they think machine learning can solve their issue, but what is machine learning and is it actually the right tool for it? So additionally, they don't really have a data science department, but they do have a data safety team, and the team's main skills are SQL and C#, and they're currently building on the Microsoft stack. So let's try to understand what machine learning is, so we can fix the problem of having one store that has too many products and the other store have nothing, so we want to have a nice equal split. So, what is machine learning? Well, machine learning starts out of different phases. We have AI. So AI is a technique that enables computers to mimic human intelligence. It includes machine learning, and it's important to understand the relationship between AI versus machine learning versus deep learning, where machine learning is a subset of artificial intelligence that includes techniques such as deep learning, that will be the next step, and that enables machines to improve at tasks with experience. In this case, the learning process. It's based on following steps. We need to find an algorithm with data by providing it with more information, use this data to train a model, test and deploy the model, and then consume the model. Now, underneath machine learning, we have another step, and that's deep learning. So deep learning is a subset of machine learning and is based on artificial neural networks that permit a machine to train itself. In this case, the learning process is called deep because of the structure of artificial neural networks consists of multiple input, output, and hidden layers, as we discussed already before in our previous session with the custom vision API. Now, if we compare traditional programming versus machine learning, what's actually the difference? And so in traditional programming, we will have data and we will have certain static business logic. We will call it here in this case algorithm. We go through some computation and then we get the output. Now with machine learning, we will still have our data which are the features. Every column is different features. Next to that, we will also have the outcome that we will add into it, and these are our labels. So a circle with two circles on top of it, for example, will be the output Mickey Mouse. And then as we will do some computation, what will be returned is the algorithm. And the algorithm will be saved as our model. Now, tailwind traders probably could try to build different rules engines with static logic to solve the problem. However, this would mostly likely take longer, be less accurate, and take more time to adapt to future trends. So with machine learning, we can build an AI model that learns from their previous sales data to predict the future. But when you start building a model, you generally think about what is the question I'm trying to answer. Well, tailwind traders want to predict how many items it will sell of different products from different stores over the next 4 weeks. This will help Tailwind keep the shelves stocked and reduce the probability that the store will run out of an item, and this allows them to maximize sales at each store. So, our question is, what are the forecasted sale quantities per item per store for the next weeks? This is called a time series sales forecasting model. So, you have different kinds of decisions that you can make, and depending on the question you have, you need to choose different algorithms. So if you have questions like how much or how many, then you'll need to look for a regression algorithm. If you're trying to figure out, is it Mickey Mouse or is it Minnie Mouse or is it Donald Duck, well, then you're classifying items and you're looking for a classification model. If you're trying to group certain items, maybe you want to group specific customers depending on how they're acting within your shop or depending on the products they buy, well, then we're talking about clustering. If you want to figure out very strange sales activities or fraudulent activities, well, then you will need to use anomaly detection. Another one that we've already discussed also before with the personalizer API is recommendation. If you want to help your customers to decide, okay, this might be interesting for you also, well, use a recommendation engine. So if we split this up, we have supervised learning and we have input and output that we can use to train our model. And then we have unsupervised learning, where we don't actually know what the output will be, but the machine learning models will generate an output for us. So how does a machine learning model building process look like? Well, first of all, we need to prepare our data. That's always the first step and most of the time also the biggest part of your job. So we need to find, select, and or create data, apply pre-processing and fill gaps in data. Second step is train your model. So once you have your prepared data, it's time to test different machine learning models to see which get the best results for your data. This is an iterative because you need to change the data and or the model until you think you have a candidate production model. Now, you've trained your model, now you need to test it. And you need to think, is it going to perform well? And you can test it with unseen data that your model doesn't know. That's why we also will see later on, we need to split our data and a training part and a testing part. So the whole testing is an iterative process, as you may need to go back to the beginning and change data features or processing until you decide, okay, this is good enough. And then our last step is actually deploying our model. So once you've chosen the one, also known as your chosen model, it's time to operationalize it so you can consume it from different applications. So, preparing our data. So starting with step 1, Tailwind traders need to do what's called feature engineering, which is the process of using domain knowledge of the data to select and create features that make machine learning algorithms work. And the feature is just an additional variable that is used to help predict or label. To select and create features, we need to ask ourselves and our team, what data would I use to make a decision? Then do I have that data and do I have enough of it? 80% of machine learning is data. If you don't have the data, well, then you can't build a model. So let's look at the data of Tailwind traders, what they need to get their data ready for machine learning. So they need to find and validate if they have enough data. And they need to have, for example, for Tailwind, they need to have at least 1 year of data to create their model. Their customers already collecting and storing weekly sales quantities by store and item, and then they apply business rules to select the data and verify if we have at least 1 year worth of data. Well, and in this case, we actually have 3 years data. So once we've had that data, we need to handle incomplete and missing data values. But now we could also add extra external data to improve the model. They would like to include the economic index to get an idea of the buying power at the time of the sales number. We want to capture the economic index in addition to the actual sales to answer the question of what the current personal buying power is in addition to past sales trends. There's a separate data point called real disposable personal income, and we're going to add this to our existing time series data to capture the economic index in our training data sets. And what we then need to do is we need to add future dates to the data set to get a prediction. They need to add the futures date that they need to get predictions for. So we need to give the data set and before or for what dates you want to predict. So let's look at all these feature selection and processing it a bit more in detail. So now we have the resulting data set of store ID, item ID, a timestamp, and of course our value. Now we will add the personal income index. Tailwind tried to decide to add that economic index. And we did the selecting part but not the create. For the time series model, we need to create more data points to improve our model performance. So the goal of feature engineering is to provide strong and ideally simple relationships between new input features and the output labels for the supervised learning algorithm to model. We are going to exclude the actual time number as this is considered as an index and not a variable in time series. Instead, we will extract the time information from the timestamp and will create additional features with that information. So this means extracting values like year, month, week, season, and holiday features and Fourier features and lag features. You're familiar with the first three concepts of time. You may not have heard of Fourier terms and lag features. So what are Fourier features? It's to capture seasonality. Basically, a number results of mathematical operations to capture the up and down patterns of seasonal effects on sales. So seasonality is an adaptable time measurement that can be changed for each model. In our example, our seasonality is each week in the 52 weeks in a year. And lag features are valuable at prior time steps. For this model, our lag will be 26 weeks for each date row. Lag features give context of sales happening around the same date, which is also referred to as autocorrelation. Now, we'll go through a live demo in Visual Studio Code. And let's see how everything is done to create this data set. So our resulting data set will then look like something like this. And we will have in the first columns is the data that we've already captured. And then we have all the extra features that we are generated plus the lag. So it looks like this with our created feature added. Let's have a closer look at it. So, okay. So additionally, if you look at the value column, while it hasn't changed, we conducted a log transformation. Okay. So now let's have a look of how we generate that data. I don't want to show this. So let's have a look now on how we can get all this data in different steps. So what we start with is this. Well, this is actually the resulting data set that we want to get. So let's have a closer look at it. So the first thing you will notice is that the value column, the values got changed. What we did is we conducted a log transformation on the values. You might ask, okay, why process a log? Why do a log transformation? Well, the log transformation can be used to make highly skewed distributions less skewed. This can be valuable both for making patterns and the data more interpretable and for helping to meet the assumptions of inferential statistics. It's some kind of normalization, and the goal of normalization is to change the values of a numeric column in the data set to a common scale without distorting differences in the range of values. So, to say it in simple words, when you have a range of many different numbers, we want to convert it and normalize it to a range of less numbers. So this is a main big part within our preparing our data. And as you might see also, we've added, of course, the other items, the year, the month. That's just a split up of the date. Now we go to our second part, and that's an important step also, of course, and that's training your model. So let's see together how you can start training your model, and most importantly, select the right algorithm for your data science problem. So one of the hardest things when starting out with machine learning is, what algorithm do I need to use? Well, the answer to that question is, what machine learning algorithm should I use is always, it depends. It depends on the size, the quality, and nature of the data. It depends on what you want to do with the answer, and it depends on how the math of the algorithm was translated into instructions for the computer you are using. And it depends on how much time you have. Even the most experienced data scientist can't tell which algorithm will perform best before trying it. What you see here, this is a difficult word for me to pronounce, the machine learning cheat, and it's for your best friend, and it should be your best friend. From start, you can think about what you are trying to predict, and it will help you make decisions on what type of model you want to build. So we are trying to predict values, so we want a regression model. So there are different types of regression algorithms to choose from, as displayed in this, I'm gonna say this slide. So we have here this list of items where we have, for example, a fast forest quantile regression, a linear regression, a decision forest regression, and so on. So we already have trim down the list of algorithms we can try. Now we can go further. Now, a nice tool that Microsoft has built is the Azure Machine Learning Service. It's a cloud service that you use to train, to deploy, to automate and manage machine learning models, all at the broad scale that the cloud provides. Now, to give an overview of the different tools in Azure Machine Learning Workspace, well, we got some nice descriptions from the docs, but we'll go over a couple of things. So we have automated ML. We'll discuss this more in depth later on in the last session of today. We have the Visual Designer, which is a visual interface for Azure Machine Learning services, where you have a drag and drop system to build your model. You have the classic notebooks, where you can write Python code in. And then you have the different assets, and you have your data sets where you can save all specific, you can kind of call it some kind of catalog where all your data is nicely stored in. It's linked to a storage. You have the different experiments that you've been running. You have your pipelines, where you go from extracting the data, preparing to training, and so onwards. And then of course you have the whole management, where you keep your computes, which virtual machines are you going to use. You have your data stores where your data sets are linked into, and of course your workspaces. In this session, we're going to be building with the Visual Designer, which uses many of these features behind the scene where you are when you are building a model. So we'll show this in a demo. So in this demo, we will focus on how you can test and deploy your model. Now, we will learn together how to build, test, and deploy your machine learning models on Azure, not specifically locally. And to conclude, you can see that in this session we have completed the 4 steps of the model building process. So we will now learn together how to build, test, and deploy your machine learning models on Azure. So we go to the Microsoft portal, of course, and we start with creating. We go to the marketplace and we create a new machine learning service workspace. Usual, we will add a name, we choose a location, just as any other resource. So once we have that, we click on, you see we have the service on itself, and we go to the preview. We click on visual interface, and we're going to create a new item. What you see here on the left side is all the items that we've discussed already in our previous slides. So we go to the visual interface and we launch it. So we also have our data sets here, where we already have our training data, forecasting data, and so onwards. So now we want to add a data store. We'll call it forecasting data set. We connect to our data or blob storage where our files are stored. We select the data set and we choose the file that we want to use. You can give it some description, and there we click done. With this, our data set has been created. We now go to our visual interface. It's loading, and now we see that our new data set is available there also. So now we want to create a new experiment. we will start from scratch with a blank interface. And what we want to do now is to, well, what you see here on the left side is all the different modules or tasks that you can put into the UI. So we selected now our data set, and now we want to select a different not samples, so we have also different samples, but now we want to select a specific algorithm that we want to use to train. So what you see here, also different items, you can still add extra data. So we have our Azure Blob Storage, where we can add data from a web URL, like getting from REST API and so onwards. But in this case, we don't need that. But we want to start with cleaning up our data a bit. So as you see, we have many manipulations that can be done to the data. And there in machine learning, we have all the different tasks that we can see to evaluate the model, to train a model, and then also initialize models. So we're talking here about classification, clustering models, and regression. And then, of course, also scoring the model to see if actually the model was doing well compared on versus our training data and test data. What we can also do is execute just specific own Python codes if you want to do that. If you are used to writing Python code, then maybe you just need to use the Jupyter notebooks, but that's up to you. So what we want to do now first is select certain columns out of our data set. So we just drop it into the portal and link it to each other. So now we can select what columns we want to keep and what columns we want to ignore. You can use both also, mixed. So here we are excluding time because we are only interested on daily level and not on time level. Alright, so if we click now run, we need to select also a compute. I'd already created a compute, but we can create a new one also. So we just say run. Now the data is going to get collected, took into memory of the compute. Here we have also an overview of our compute, so you can see what kind of virtual machines are behind it. Is it machine learning compute? Is it Kubernetes compute? Or maybe it's even a Databricks environment, which is also possible. So in this way also we can create a new compute. In the background, our model is still trying to be sent to the environment. So here's the different items we can have as compute sources. So Kubernetes, a virtual machine, Azure Databricks, Data Lake Analytics, or HD Insights. And then depending on what you've selected, you can choose also what kind of virtual machine size that you want to use. And again, also the minimum number of nodes and the maximum number of nodes, which is interesting. Because if your minimum node is 0, it means when there's nothing going on, all your nodes will switch off. But it means also when you start up an experiment, it takes a while before your first node has started working. So keep that in mind depending on how fast you want to do your experiments. But especially if you deploy it as a web service, it's better to keep at least one running so your users don't need to wait for your machine to come up. Now, within the tool, we can have a look again at our data, where we see all the items that we've added. We have our value, our personal income index, we have the year, and so on. And then we have some extra features that we generated based for seasonality. So here you can see our values that are nicely evenly split up. So we also see here standard deviation, what's the median, what's the minimum, what's the maximum value. So it's a nice way already to look into your data because you have a nice summary of everything. Now we want to split our data. We say, okay, our data is clean. And now you can say how many % of your data needs to be split for training data and for testing data. So we'll say now 70% training data and 30% testing data. So now we have that. There's some extra features you can configure, like a random split, so it doesn't take just the first 70 rows and so on. Now we want to train our data, so we add the train model block to it. Then we want to score it, and now we also need to select what, and of course we want to evaluate it. And now we can add our model, so we are looking for a regression model, and we will start with a boosted decision tree regression. So here you're just saying, okay, this is the kind of model that I want to use. We link this to train a model, and we link. So we split the data, and we have the split data 70% for training, and then 30% will be used for testing or scoring, where the trained model will be sent to the scoring. So we can use that model to score the test data and see if the outcome is good. And then that results will be sent to the evaluate model, which will give us a nice results of what is going on. What we still need to do then is connecting the model, the algorithm that we want to use, and we link it to the train model. Now, in train a model, we've just selected what value we want to predict, which again, we say what compute target we want to run, and we just run it. So now it's just waiting until the process is done. So now our model has been trained. We have everything that we need. What we've added is some small extra scripts to clean up some things. And now what we can see is our columns, what we'll look into. So we extract it and we'll visualize it now. So we have again all the values that were already in our data set, or values that we have here. And we have our scored label, which is our predicted model, or predicted value. Or if we do our evaluation, we also see what all the different measures we can see to compare if our model was doing well or not. Absolute error, squared error, and so onwards. If you want to have more information about that, you can always find it in the quick help. So I'll fast forward a bit. So you can always, this is the information where you see what all these measurements mean that we get through the evaluation. So in this case, when you click on the algorithm we selected and you click on quick help, also there you will get more details about the algorithms and what items, what features of that algorithm that you can fine-tune to get maybe better results. So if we visualize now the results, we have a nice view of the actually target because we denormalized it back in the Python script, and we have all the data together. Sorry, just okay. Okay, so what we want to do now is we want to save it so we can use it as a web API. So we click the create experiment. You see some small things are going on. So what happens now is that we have a predictive experiment and a training experiment. What we're looking now is so this is the training experiment is what we were making, and now we're at the predictive experiment, where the input is of course not the file anymore, no data set anymore, but it's the input of the web API. So again, we will need to select a certain compute behind it. But what's actually behind this is the saved model that is already in the dataset. So what we've done here is a Python script that will bring back the values to the normal values how it was without the normalization, and we select the columns that we want to have as outputs of our web service. Now we just need to click deploy. Again, depends on what service you want to deploy it on. You can send it to a Kubernetes system. Just give it some small time to deploy. And now if you look to compute, you can always add extra to it, new ones. So now that it's done deploying, we can use it for a service. So if we go to web services, we will see a web service got added. If we click on it, we will get all the data of it. We can test it there locally and see what results we get, or we get all the keys and even an example in C#. What are the endpoints to be able to use it within your application, or to use it in another Python script, for example. So in this case, we just need to add the data to our C# project to generate the extra data. So to conclude, you can see that in this session we have completed the 4 steps of the model building process. I would say congratulations, you're now able to prepare your data, train, test, and deploy your own machine learning models. I know it went all quite fast. It's a lot of things a lot of new things for most of us, I guess. But don't worry, there's a lot of docs and Microsoft Learn where you can upgrade your knowledge about how to use it. There's a lot of good resources for you to go back to work and start building a lot of tutorials on Microsoft Docs and Microsoft Learn, and a lot of full of great tutorials to continue the journey we started today. So I would say thanks already for your... Now I lost my words again. Thank you for keeping your focus for the last 3 sessions. Let's have a lunch break now, and then we will be back in a bit to discuss the next 3 other sessions. So see you in a bit. Bye.